Okay, so this angular quantum number, oops. So we have N. So N basically the shell, the principal quantum number, and L is the angular quantum number that represents the shape of the orbital. Okay, so this is subshell. And we have ML. ML represents the number of orbital. Okay, the number of orbital for the subshell. Okay, all right. So this is the number of orbital. And last but not least is the electrons. Electrons properties. Okay, the electrons itself. So these three quantum numbers describe the orbital itself. Okay, these three quantum numbers describe the orbital. On the other hand, MS describes the electron itself. Okay, the electron itself. So this is the orbital. We use these three quantum numbers to describe the orbitals that the electron occupy in, whereas the MS is the electron spin. Okay, the properties of the electron itself. So we have for MS we have positive half, negative half, and positive half. These two is not dependent to NL and ML. It's just that we should know that in one orbital, okay, in one orbital, let's say we have one s orbital, so the maximum number of electron that can occupy this orbital is 2. Okay, all right. So let's say this is positive half, and this one, Allahu Akbar. Okay, this is one s, so we have one pointing up, the other one is pointing down. So this is positive half and this is negative half. Okay, if we have 3 orbitals, which is a p orbital, for example, we have 2 p orbital. So if all of the orbitals are fulfilled, penuh, okay, fully occupied, that means we have positive half, this one is negative half, this one is positive half, this is negative half. Okay, this one also positive half. This is also negative half. Okay, so there are three electrons having the same spin, and positive half. Okay, and the other three electrons having the same spin, which are negative half. Okay, all right. So this is just an example. So same goes for d orbital. So for d orbital, okay, so we have 5 orbital in for d-shaped orbital. So by right we should have 5 electron having the same ms, which is positive half, and the other 5 electrons having the same ms, which is the negative half. Okay, right. Okay, so this is like the summary, and this is we have discussed this yesterday. Okay, and we also have discussed this checkpoint, the total number of orbitals associated with the principal quantum number, and we also discussed about the number of electron that can occupy the principal quantum number n is equal to 3. Sorry. Okay. All right, so next checkpoint we have determined the total. So this one have been discussed yesterday. Okay. Question 2, write the 4 set of quantum number for each electron in a 3p subshell. Okay, remember I have mentioned this earlier on while we were on the topic of the orbital itself. Okay, so to locate an electron, okay, we will use the quantum number. So we have 4 quantum numbers. Okay, so these 4 quantum number kita boleh groupkan dia into one set of quantum number. So one set of quantum number should consist of 4 quantum numbers. Okay, which is which have N, L, ML, and MS. So for one electron, okay, each electron should have its own quantum number set. Faham tak? Untuk satu elektron kena ada N, L, ML and MS. Okay? Alright. So to answer this question, write the four set of quantum number for each electron in a 3p subshell. So how many electrons are there in 3p subshell? Okay, we have the subshell is 3p subshell. That means we know that the N is equal to 3. Okay, how about the L? So what's the value of L, guys?
012.
Based on this, okay, based on this given subshell, so it is already specified that it is 3p target. Yes, it should be 1. Okay, sebab dia dah specify. Kalau dia kata N is equal to 3 only, that means your answer, your L should be 0, 1, 2. Okay, tapi dia dah specify that the N is 3 and the orbital is P. P is equal to P is equal to L equal to 1. Okay, so ni kena take note. This is the N, this is the L. Guys tu Alright, so this is a p orbital. So we know that p orbital should have how many orbitals, guys? How many orbitals are in the p-shaped orbital for the p-shape? Sorry? 3. So we have 3 orbitals for p-shaped orbital. Okay, 3 orbitals for p-shaped orbital yang macam ini tu. Okay, and then buruk sikit lah tapi macam ni lah. So kita ada 3, Px, Py, Pz, or we can also name them as, numbered them as -1, 0, +1. So how do we know that it is -1, 0, +1? Because it depends on the L, betul tak? So the ML should be -1, 0, 1. If you were to assign this, so it will become like this, -1, 0, 1. So this is a 3p subshell. Okay, so all of this is a 3p subshell. So if all the orbitals are fully occupied, how many electrons are there in the orbitals?
6.
Yes. Okay, there are 6 electrons in 3p orbital. Okay, so kalau penuh, this is how it looks like. Okay, you may wonder kenapa saya letak dia, saya tak fulfillkan each orbital first. Saya kena fill up and then I come back to fulfill all the orbitals. Nanti you akan tahu why. Okay, alright. So in total we have 6 of them. So each one of the electron here should have its own set quantum number. Okay, alright. So let's go for this one. This would be our first electrons. Let's just assign this as our first electrons. First, second, third, fourth, fifth, and sixth. Okay, alright. So each one of them should have N, L, ML, and MS. So how do we assign set quantum number for each electron? So we use bracket. Okay guys, kita guna bracket. So for each electron we should have N, the value of N, L, ML, and MS. Okay, alright. So now, please tell me what is the value of N? Okay, what is the value of N for the first electron? What is the value of N for this first electron? Value? Guys, come on. Sorry? Tak dengar?
3.
Yes, it's 3. How about the L, guys?
1.
Wow.
Yep, it's 1. Okay, how do we know this? From this. Okay, and then how about the ML, guys?
-1.
Yep, -1. And how about the MS?
+half.
Yes, because it is pointing upward. Okay, so it should be +half. There you go for your first quantum number, okay, for the first electron. So, for the second electron, what will be the N?
3.
Yep, 3. And then L?
1.
1. And then ML?
-1.
Yep.
Negative 1.
And then how about the MS?
Negative 1.
-half.
Negative half. Okay, so boleh imagine tak the rest tu, apa yang remain the same?
NL and
ML.
ML.
N and L. Okay, N and L will remain the same for all of the electron because they are in the same orbital, in the same subshell. Okay, right. So kena buatlah untuk all of the electrons. So it will be 3, 1, and then the third one will be 0, and then positive half. Okay, and then kena buat semua, tulis, jangan malas please. 3, 1, 0, negative half. Okay, comma, and then the fifth electron should have 3, 1, positive 1, positive half. Okay, the sixth electron should have 3, 1, positive 1, negative half. Okay, so this is how you assign the set quantum number for each electron in the orbital. Okay, so as you can see, none of them are exactly the same. There mesti ada at least one quantum number that is different. Because apa? The quantum number, the set quantum number is unique for that particular electron. It's like DNA lah, dia tak entirely the same for for electron. Dia mesti at least there's one quantum number that will be different than the rest. Contohnya kan, it's like so first and the second electron, okay, they only differ in terms of the MS. Same goes to the third and the fourth electron, they only differ in terms of MS again. Okay, all of the N, L, and ML are the same, but not for the MS. Okay, so they are unique. The quantum number is unique for electron. So each electron should have different quantum number lah. Cannot be the same for 2 electron. Okay, it cannot be the same for 2 electron. Okay, all right. It depends on the question. Okay, please make sure you address the question. If the question is asking for the set quantum number for the electron. Okay. Yep. Okay, all right. So now let's move on to write the values of N, L, and ML in the 3D subshell. So the N would be, guys, what would be the N?
3.
3.
Okay, so this is the N. And then how about the L?
2.
Because we are talking about D now. Okay. Unless dia tanya N is equal to 3, then we could list out the L. So 0, 1, 2. Now it is already specified in the question that the subshell is D subshell or D orbital. Okay, then the L should be 2 lah. 2 is equal to D. Okay. How about the ML? How about the ML, guys?
-2, -1, 0, 1, 2.
Alright, good, very good. -2, -1, 0, 1, 2. Okay, just list out. Okay, sebab dia tak mention for any of the electron ke in the 3D subshell, so we can just list out as this. Okay. Alright, yeah, this is the answer just now. Question number 4. So we discussed about this in the earlier checkpoint. Okay, determine the maximum number of electron that can be occupied in the principal level for N is equal to 3. Okay, remember we have the previous question asking for the total number of orbital for N is equal to 3. In fact, kita dah extend a little bit on the electron. Okay, for N is equal to 3. Okay, so the answer is, so the total will be 18 lah. Okay, total up everything we got 18. So these are the subshells that can be present in the for N is equal to 3. Okay, so this is S, this is P, this is D. Okay, Alright, okay, we are done with that. Next, let's move on to atomic orbital. Okay, remember in yesterday's lecture, I have added in one additional slide. Okay, saya ada tambahkan additional slide kan, sebab I feel that it is important for you to know ataupun to have an idea of the shape of the orbital. How does the orbital looks like? Okay, you nak kena tahu. So you need to have that introduction to the shape of the orbital. So dia ada dalam slide tapi dia later in the slide, which is here lah. Baru dia nak introduce the shape of the orbital. Okay, so luckily kita dah cater in the earlier slide. So patutnya this is like a macam apa revisit for you okay. So for this atomic orbital, make sure that you are able to explain the shape of orbital in terms of electron distribution, and make sure that you are also be able to sketch the shape of S and P orbitals only, not for D and F. So the target will be for S and P. Okay? Alright. So like what we have discussed in the previous slide, okay, for Schrödinger equation, okay, the wave function represent the orbital. So what is orbital? Orbital is the probability of finding electrons is more than 90%. Okay, so finding an electron, to find an electron in a region of space ataupun to find electrons in a region of space is called electron distribution. How the electron are being distributed, okay, dekat that specific region, which is called orbital. Okay, so distribution of electron can be described using electron density. So we will be based on electron density. Okay, sebab apa? Because electron is not localized. Dia tak duduk setempat. Dia always on the move. Dia sentiasa bergerak. In fact, we do not know exactly the location. So what we can do is to predict the kawasan yang dia suka duduk dekat situ. Okay, so that is called electron density. So the density of electrons are delocalized. Okay, dia delocalized, dia duduk bersepah kat mana-mana kan, tapi dia ada favoritism dekat situ. Okay, so that is why bila dia delocalized at that particular region, okay, kita boleh katakan the electron density at that region. So it will form orbitals. Okay, it will form orbital. So a collection of orbital contributing to the overall size and shape of an atom. So imagine all the orbitals are combined. Okay, imagine we have an atom. So in the atom we have for elements that having more than one electron. Okay, for atom that is that has more than one electron. Okay, so imagine dia akan ada numbers of orbital involved. Okay, for the electrons punya orbitals. So a collection of orbital contributes to the overall size and the shape of an atom. So imagine kalau S combine dengan P, combine dengan D, combine dengan F. So apa yang kita nampak? Okay, so it's more on the overall shape of the atoms. Okay, right. So this is an S orbital. This is a representation of orbital. So orbital depiction provide maps of how electrons are distributed in space. Okay, so look at A. A is the graph. Okay, so kita boleh represent A. Okay, kita boleh correlate A with B. So as you can see, we have the graph. So electron density versus the distance from the nucleus, which is R lah. Okay, so we have kita ada bukit kat sini kan. So here and then dia turun lembah, lepas tu bukit lagi. But this time around the electron density is higher than the first one. Okay, alright. So this the first the first graph ni, bukit yang pertama represent the one the orbital that is closest to the nucleus, which is this one, yang the red colored one. Okay, yang lembah ni, yang dia turun ni, this is the node ataupun where the electron density is not is zero. Okay, where the electron density is equal to zero. Maksudnya there's no electron at this region. Dekat warna putih tu there's no electron. Okay, and then we have another bukit yang lebih tinggi. So this would be the second orbital. Bukan, the second 2s orbital. Yep. Okay, second to s orbital lah. If we are because currently we are referring to s orbital. Okay, right. So example of electron density distribution A, electron distribution plot in 1s and 2s. So this is, kita boleh assume that this is 1s and this is 2s. Okay, alright. So B is the 3D nature of 1s and 2s. Okay, so the red one yang tengah ni will be 1s kalau kita nak represent that, and then we have 2s. It's the same thing. This is in terms of graph, this is in terms of the electron density itself. If we simplify this, okay, for an atom, this is what we see. Okay, kita nampak dia bulat at the end of the day. This is only s orbital. Can you imagine if you have orbital S, P, D, F all combined into one. Okay, so that's why kita nampak the atom is more on spherical shape. Bila dia dah overlap each other tu. Okay, so what we see is more on the spherical shape. Okay, shape of the orbitals. So the quantum number that determines the shape of the orbital lah. So the shape of orbital can be determined from the angular quantum number. Okay. So each value of L is called by a particular letter that designates the shape of the orbital. So S orbital will be spherical, P orbital like two balloons tied at the knot, or dumbbell, or cuping the lobe kan, two lobes. Or you can use two lobes. Okay, for D orbital mainly like four balloons tied at the knot, or four lobes. Okay, all right. So this is what I meant just now. So we have S, we have P, D, and then F. Okay, what happened bila dia combine? So what we see will be the spherical shape of the atom. Right? Ini kita dah cakap kan hari tu. So L is equal to 0 is equal to S orbital. So each principal energy level has one S orbital. So each principal energy level, this is N. Okay, so maksudnya 1, if N is equal to 1, that means we have one S orbital. If N is equal to 2, that means we have 2 S orbital. So for each, okay, for each principal energy level, will have one S orbital. Faham tak? Mesti ada satu S orbital. Okay, sebab apa? Again, okay, kenapa ada S for N is equal to 1? Because the L, remember N is equal to 1, therefore the L is only 0. Nampak tak? N is equal to 1, the L is only, we have L is equal to 0 only. We do not have L is equal to 1, 2, and so on, because it depends on the value of N. That is why if N is equal to 1, there is one orbital available. Okay, only, which is the S orbital. Not P, not D, and so on. How about N is equal to 2? If N is equal to 2, the L will be 0 and 1. Okay, maksudnya dia still ada this S orbital. Nampak tak? And then dia ada P lah. Tapi P akan start for N is equal to 2. Okay, not for N is equal to 1. Okay, same goes to if N is equal to 3. That means the L will be 0, 1, 2. So that means we have S, P, and D. Okay, so kat sini kita boleh conclude that for each principal energy level, we'll have one S orbital. Okay, so it is the lowest energy orbital in a principal energy state. Dia yang paling rendah energy. and it is spherical, and then as n increases, the s orbital gets larger. Nampak tak? So this is 1s. As you go for 2s, okay, basically the shape will remain the same, but the size now become larger. The size increases. Okay, this is for 3s and 4s and so on. Okay, this will be the p. Okay, kita dah introduce the p just now in in angular quantum number. So we have px, py, pz. Okay, so how to draw px, py, pz? So it depends on the axis. Okay, so if it is px, okay, if it is px, that means you have to draw on along the x-axis. Okay, along the x-axis. If it is a py, that means you have to draw along the y-axis, and same goes to pz. Okay, cuba tengok dekat sini. So for p orbital, the value of L is equal to 1. Okay, each principal energy state above n is equal to 1. Okay, above n is equal to 1 has 3p orbital which points along a different axis. Okay, maksudnya n should be more than 1 baru ada p orbital. N is equal to 1, okay, no p orbital. There is no p orbital. Tak ada p orbital. The p orbital will start at n is equal to 2. Kenapa? Okay, because L is equal to 0 and 1. Okay, then only kita ada p orbital. Nampak tak? Harap awak faham dekat sini. Kenapa n is equal to 1, there's no p orbital. But the p orbital will start from n, for n is equal to 2. Because when we list out the L, we have that L is equal to 1, which represent the p orbital. Okay, all right. So this is the second lowest energy orbitals in a principal energy state. So when we compare S and P, okay, S is the lowest. S has the lowest energy, and then followed by P, and then we have D. F has even higher energy. Okay, all right. So D pun sama, okay, dl is equal to 2. Okay, if L is equal to 2, we know that it is a d orbital, okay, principal energy level where n is equal to 3 or greater. Bila n is equal to 3 and greater, that means then only it will have apa nama tu, d orbital. Kenapa? Cuba tengok. Okay, n is equal to 1. The L will only have 0, which is the s orbital. Betul tak? If n is equal to 2, the L, okay, we have 0 and 1. This is s orbital, this is p orbital. See? Okay, but we don't have d for n is equal to 2. If n is equal to 3, then we have L is equal to 0, 1, 2. Okay, so this is S, this is P, and this is D. So as you can see, the d orbital is only available when n is equal to 3 and above. Okay, maksudnya kalau n is equal to 4, that means the L should equal to 0, 1, 2, 0, 1, 2, 3. So this is S, this is P, this is D, and this is F. So nampak tak? Starting n is equal to 3, okay, we have the d orbital. Okay, that's why they kata greater. This is the same as what we have for p orbital. N is equal to 2 and greater. Mungkin ayat ni agak tak berapa sampai. Maybe you can change it to when lebih kurang kat sini. Principal energy level where n is equal to 2. Okay, principal energy level where n is equal to 2 and greater. Okay, barulah ada p orbital, p-shaped orbital. Okay, alright, so draw the following orbitals. Okay guys, please complete this checkpoint. Try to draw the following orbitals. Okay, for S, P, and Y. And then make sure you sketch, your sketch should show the differences between these orbitals. okay, in terms of size, shape, and orientation. Okay, so please draw. I would highly suggest you to draw on the same axis. Okay, so meaning that you should have one axis lah. One axis bukan maksudnya satu set axis. Katakanlah ini you punya axis. Okay, so you should have 2S and 3S on the same axis. Faham ya? So try to draw it first and then we will discuss it later on. I'll give you 2 minutes for this question, okay? Anyone has any question? Okay. Okay, so let's discuss the answer. Draw the following orbital. Make sure that your sketch should show the differences between the orbital mentioned in terms of size, shape, and orientation. Okay, so let's start with A. So both orbitals are S orbitals. Okay, so but we have 2S and 3S. So this is this can be drawn in terms of different size. Okay, we know that S is has a spherical shape. Okay, S orbital has spherical shape. So okay, so maybe you can label Y, X, or Z. Maybe. Okay, alamak. Okay, so this is Z. Okay, all right. So label. So this is S, 2S, for example. Okay, let's change to another color. Let's have blue. So this would be, oops, alamak, apa tu? Okay, so this is 3S. Make sure that you label. Okay, you must label your sketch ataupun your drawing. So for the red one just now, we have this S2. S. Okay, maybe we can have arrow there. Yep, this one is blue color. Yeah. Okay, alright. So for px, so 2px and 3px, both of them, both of them also px, okay, but they differ in terms of the value of n. So one has n is equal to 2, okay, the other one has n is equal to 3. So we may draw the size of the px for 2px and 3px. Okay, kita increase more on the 3px. Alah, sama lah like what we have in A. Okay, so but now we have to draw for p orbital. Okay. Okay, so this is x, this is y. Okay, so let's draw for 2px first. So this is 2px. That means it should be drawn along the x-axis. Okay, label. This is 2px. And how do you differentiate this from 3px? That means you have to make it larger, okay, for the 3px. Okay, so, yep, this one. This is 3px. Okay, they have the same axis. So because they differ only in terms of n. Okay, the value of n. Okay, alright. Next will be yep.
Z-axis saya lukis ke?
Nak lukis, it's not a problem, tak ada masalah. Boleh include. If there is no z-axis pun tak apa. Because what we are trying to highlight is on the x-axis. Okay, not the z-axis. Tapi nak ada, not a problem. Boleh lah letak. Tapi kita tak guna pun. Okay. Aduh, sorry lah buruk Ayo. Okay, z. Letak. X, Y and Z. Okay. Buat je, tak apa. Kita complete X, Y and Z. Okay. Alright, C, PY and PZ. So the value of n is the same for both, but they differ in terms of the axis. Okay, dia punya orientation of the p orbital. So one is y axis, is along the y axis, and the other one is along the z axis. Okay, so this, aduh, saya ingat. As long as you label, Okay, I want this to be y, and this is, okay, let's just follow the axis that we have here. Okay, for both sketches. Okay, so let's have the z here. Sama lah, kita maintain. So this will be the x, and this will be the z. Okay, tak kisah, dia boleh juga ada dekat x ni, as long as you label. It depends on how you label your axis. Okay, so so it should be drawn along the y-axis. Okay, this will be your py. Okay, maybe I want to change color to purple. Okay, so the pz will be, the pz will be like this. Yep. Okay, so this is PZ. The green one will be the PY. Hilang ke apa purple tu? Okay, alright. So this is they differ in terms of orientation, okay, but not in terms of the size. So the size should be more or less the same lah. Okay, it should be more or less the same. Janganlah beza sangat. Okay, so A dengan B, they differ in terms of size. C, okay, they differ in terms of orientation on the axis. Okay, any questions so far related to atomic orbital?
Madam, kalau nak label, tak apa ke kalau buat arrow, sebab arrow bukan ke macam shows there is movement dekat situ selalunya kan?
Arrow, come again?
Arrow bukan ke selalunya macam menunjukkan ada movement of something lah, apa-apa. So tak apa ke kalau label ada arrow?
tak apa, sebab we are labeling lah, kita label kan, kita label to differentiate. Okay, dia depends lah, sometimes the arrow shows the movement, tapi in this case the arrow shows that we are labeling the which orbital belongs to which orbital, which orbital belongs to which label. Okay.
Okay. Thank you.
Ataupun to be tak, sebab bila kita letak arrow because kita nak, kadang-kadang kita takut kita miss out kan. That's why bila ni, okay, this is the blue one, we are referring to the blue line dekat situ. Okay, kalau tak nak buat arrow macam ni, just buat garis je pun okay kok. Kalau tak nak apa nama tu, tak nak macam nampak macam dia ni yang mana satu ni kan. So tak payahlah letak arrow, just buat garis saja. Okay, right. Or alternatively, you can also just label on the sketch itself. Maksudnya ni label kat sini, this is 2S and this is 3S. Macam tu. Banyaklah alternatif, tapi kena label lah. Okay, the most important thing you have to label, then only we know which orbital that you are referring to. Kalau you tak label, masalah lah kat situ kan. Ni 2S ke ni 3S. So kena ada label lah. Okay, how do you go about to label your sketch? That depends on you. Maksudnya kita tak rigid on you must use arrow ke, you must use anything ke kan, as long as you label. Okay? Macam ni kan. Dia tak label. Ini kita tak berapa galakkan lah for this one. Sebab 2S kita ada je. We have students that falsely label the sketch. 2S dia label yang besar, 3S label yang kecil. Okay? So how do we distinguish those student yang buat betul-betul dengan yang tahu the PX, PY, S, 2S and 3S dengan those yang tak tahu, menyorok dekat situ, so dia tak pakai, dia tak tunjuk label. Okay? So that is why you have to label. So this is saya kata tak complete lah. Okay, answer scheme tak semestinya semuanya bagus ya. Ni saya nak comment on the answer scheme lah. So this is PX. PX dengan PY yang mana? Yang mana? Tak tahu pun. So you have to label lah. Okay, so this is PY and this is PZ. Sometimes kita tengok, okay, pandai tak this student dia draw on the Y axis. Okay, so kita sometimes we are very lenient. Okay, therefore we allocate mark for student because this student managed to draw correctly of the orbital for PY, okay, because he or she drew the orbital on the Y axis ataupun on the correct axis. Okay, sometimes macam tu. Tapi kalau ni S orbital size besar, size kecil. Macam mana nak tahu 2S ni yang besar ke 3S yang besar? Okay, ni label lah. Label accordingly. Okay. Penatnya. Any questions so far before we move to the next subtopic, the electronic configuration? Okay, so kita dah start we are going to apply the quantum number, okay, that we have learned earlier in the electronic configuration. Okay, and few others application of electrons lah. Okay, in atoms. Okay, so electronic configuration, these are the learning objectives. So we have more than one here. So we have more than two here. Okay, we have 4 learning objectives. Make sure that you can, at the end of this subtopic, you should be able to cross off. Okay, cancel. Maksudnya dah checklist. This will be your checklist. Okay. Okay. So what is electron configuration? Ini application kan? Kan saya kata this is the application of quantum number just now. Okay, so what is electron configuration? Electron configuration, electron is electron lah, obviously. Okay, configuration is how do we configure the electron. So imagine we have atoms kan? We have so many atoms in the periodic table. So we have so many elements in the periodic table. Okay, so most of them, memang all of them except hydrogen, okay, they are all having more than one electron. So how do we configure those electron in the atom? Macam mana alamat dia, coordinate dia? Okay, so we have this what we call electron configuration. This is the term that we use to configure the electron. It's actually it represents the distribution of electron in the orbitals of an atom. Okay, they represent the distribution of electron in the orbitals of an atom. So how does the electron configuration looks like? Okay, this is how we represent the electron configuration. So dia mesti ada quantum number lah, betul tak? Okay, so this value represent the N. Okay, ni kita dah tahu. And then S represent the L, the angular momentum quantum number. And this subscript, yang ni yang baru. Superscript, this is what we call superscript. Dia kuasa kat situ. Okay, so this is this represent the number of electrons in the orbital or the subshell. Okay, that means for 1s1, it means that there is one electron in orbital s at n is equal to 1. Tu cara nak baca dia. Okay, there is one electron in s orbital for n is equal to 1. Okay, if it is 1s2, that means there are 2 electrons in s orbital for n is equal to 1. Okay, so this is what we call electron configuration by SPDF notation or sub-levels notation. Okay, when we have the L, it will be the sub-level notation. Okay, let's apply this for hydrogen atom. Okay, so remember this box represent the orbital diagram ataupun the room of the electron. Okay, yang kita buat ni lah, inilah box. Kita leceh lah nak buat, tiap-tiap kali nak buat box ni kan, kita boleh simply buat macam ni. Okay, so this is what we call orbital diagram. Katakanlah, so H, so we have 1s, ada satu elektron kat situ. So this one, ni. We can represent this electron configuration using orbital diagram. We can also represent the electron configuration, okay, the electron occupied in the orbital by using orbital diagram. Maksudnya kalau 1s1, apa maksudnya? There is one electron in 1s orbital. So this is the 1s orbital and the electron. How do we represent the electron in the orbital? So kita draw, this is the orbital. The kotak, the box will be the orbital, and then there is one electron kan. So one electron, maximum it can occupy 2 electron in an orbital. Maximum Tapi kalau dia ada satu je elektron, maksudnya one should be the positive half lah. Normally kalau dia ada satu, kita start standard lah. Standard kita start with positive half. It can also be negative half, tapi kita start ikut standard, kita follow standard. Okay, so we shall start with positive half. Okay, kita start ikut standard positive half. Okay. Okay. Alright, so in order to come up with the electron configuration for an atom, there are 3 principles ataupun 3 rules that we have to consider. Kita tak boleh simply okay, 1s masuk dalam 2s macam tu, tak boleh We have to consider ataupun we have to we have to be based on the rules. Okay, set for the rules in order to set for the electron configuration for an atom. Okay, so there are 3 rules. Okay, let's start with Aufbau principle. So these rules will govern, maksudnya dia menentukan how the electron configuration will be, how the electron configuration is written. Okay, macam mana nak tulis the electron configuration. Okay, so let's start with Aufbau principle. Okay, Aufbau state, Pakcik Aufbau, okay, Pakcik Aufbau state, the electron occupy orbital in the order of increasing energy level. So the electron mass fill orbital starting with 1s as shown by the diagram. Okay, alright, so the electron should occupy the lowest energy level available. Okay, if that lowest energy level is already fulfilled, then only it can go into the next energy level. Okay, Maksudnya dia kena follow from the lowest and then building up to the highest. Yelah, sebab mestilah from the lowest kan, sebab it is the easiest. Kena start daripada bawah dulu, then barulah naik atas. Okay, macam you belajar kindergarten dulu, and then sekolah rendah, and then sekolah menengah, and so on. You takkanlah baru-baru lahir masuk universiti terus kan, unless you are very special kan. Okay, normally, okay, we will go for the lowest, then building up to the highest. Okay, alright, same goes to electron. So we're gonna start with 1s first. Kita penuhkan the 1s, and then if the 1s is already fulfilled, then only we start occupying for the next sub level ataupun next orbital available. Penuh lagi baru buka next orbital. Penuh lagi baru buka next, depending on the energy. So that is based on Afbau. Okay, so we are going to start with the electron filling will start from 1s. Okay, arrows are drawn through the diagonal looping back to the next diagonal each time. The order is 1s, 2s. This is not a problem. 2p, 3s, 3p, 4s. But this is common mistake made by students. Sebab dia akan buat 3s, 3p, 3d. Okay, 3s, 3p, 3d baru 4s. Okay, so dia selalu miss out. Okay, so how do we know which orbital should be filled up first? Chart, dia punya tips dia, this is the tips Okay, we're gonna start with 1s. And then kita buat macam tangga After 1s we have 2s. After 2s kita ada 2p. Okay, kenapa 1s again lagi sekali? Kenapa for 1s we do not have 1p guys? Why is it for n is equal to 1 there is no 1p orbital? Kenapa?
L equal to 0.
Yes. Okay, brofish. Okay, so 1s, 2s, 2p, okay, and then 3s, 3p, 3d. 4d dia on, so banyak sangat nak cakap ni. Okay. D orbital is only available for n is equal to 3. For n is equal to 2, there is no d orbital. Again, the same reason that we have for n is equal to 1 just now. Okay, alright, and then so on for s, 4p, 4d, 4f. Okay, and 5s, 5p, 5d, 5f. Tapi ni dah banyak sangat lah ni. Okay, dah banyak sangat. Okay, alright, so that's why we have the arrow. So nampak tak dia macam staircase macam tangga kan. So we draw the diagonal arrow. Okay, this diagonal arrow represent how the electron occupy the orbital starting from the lowest. So we're gonna start with 1s first. Okay, so and then buat dulu arrow dia tu ya. Buat dulu arrow dia. So ni tips lah, tips and so on. Okay, next. Okay, arrows are drawn through the diagonal looping back to the next diagonal each time. Looping back maksudnya tak ada pula dia tunjuk looping kat sini. Yeah. Okay, maybe we can have green color. So kita masukkan 1s dulu based on the arrow ni, and then once the 1s is fulfilled, dah penuh, baru we go back to 2s. Masukkan 2s pun penuh, ada lagi elektron dekat situ, extra electron, go back to 2p, baru masukkan 2p. Okay, and then from 2p, baru 3s, follow arrow tu. Okay, and then 3s, and then 3p, and then 4s. Nampak tak? 3p, then only 4s, not 3d. Okay, the reason why we will see in the later slide. Okay, kita akan masuk 3p dulu, baru 4s, then only looping back to 3d orbital. Nampak tak ni? 3p, 4s, and then patah balik pergi 3d. 3d, 4p, 5s, and then patah balik for 4d. Okay, bukan main saja-saja list macam tu. You have to be based on this Aufbau orbital filling. So tips dia buat tangga ni dulu. Nanti somehow you dah pro lah. Okay, for a start you nak based on this tangga ni kan. Later nanti you dah hafal sebab you keep on electron configuration. Okay. You keep on writing the electron configuration sampai you rasa bosan dah. Sampai you dah hafal lah senang cerita. Tapi dekat sini, this is the most critical part because student tend to terbalik. Dia akan 3P and then 3D and then 4S. Sebab apa? Okay, most of the time memang they based on the value of n. So dekat sini betul. Dia follow lagi. Dia based on the value of n. So when the n increases, by right the energy will be higher kan. So we're gonna start with 1s, 2s, 2p, 3s, 3p. Tapi 4s dulu, baru 3d. Okay, and so on. Yep. This one, kenapa tadi cakap? Aku pergi kat sini. Okay, alright. So, this is an atom having how many electrons? Kena kira lah berapa banyak elektron yang ada guys tu Okay, so how do we fill up the orbital? So we're gonna start with 2, 4, 6, 10, 10, 12 tambah 12 tambah 6, 18, 18, 20, 20 tambah 10, 30, 31. So total of electron is 31. Okay, so each of these electron, each of these electrons should be placed in the orbital tau. Dia mesti ada bilik dia sendiri. So how do we place all the 31 electron in the orbital? So kita kena ada dia punya prinsip ataupun rules dia. So the first rule will be the Aufbau rule. Okay, so Aufbau said you have to fill up starting from the lowest energy and then building up to the highest. Okay, so that's why ada 1S, dah penuh baru masuk 2S and then 2P. Sebab apa? As you can see, this is the energy level. So 1S is the lowest and then followed by 2S and then 2P and then 3S, okay, and then 3P. Nampak tak ni? 4S and 3D. Okay, as you can see, 4S has lower energy than 3D. Okay, dekat sini dia dekat-dekat dia punya different dia, the energy different is not that much, but still 4S has lower energy than the 3D. Okay, alright, even though 4S, the value of n is larger than the 3D, betul tak? The value of n is larger than 4 is larger than the value of n for 3D. But we cannot simply ignore that the orbital itself pun ada energy dia. They also differ in terms of energy. Okay, the d orbital ataupun the s orbital, s has lower energy than the d orbital. So dekat sini dia kena compensate lah. Okay, alright, so we cannot just based on the n itself, kita kena consider on the d. Sebab after S we have P and then we have D. That means D is one of the highest energy, one of the highest energy orbital. So maksudnya dia punya, even though N dia rendah, but still, okay, the D orbital is considered as high energy orbital. Okay, high energy orbital. Okay, and then followed by 4P. 4P macam biasalah. Dekat sini students selalu miss out. That's why you need to use this ni tangga ni. Kalau you pakai tangga, there should be no problem. Tapi dia kalau just based on suka hati dia akan miss out. Confirm akan miss out this part. Okay, kena start filling up the 4S, then only the 3D. Okay, this is based on Aufbau. Next, okay, write the full electron configuration for sulfur and calcium. Okay guys, please try to write the full electron configuration for sulfur and calcium. Okay, cuba try based on the tangga tadi just now. Yes, question?
Madam,
Yep.
do we need to write all the orbitals until 6f or just write until we can occupy all the 16
Yes,
electron?
the latter. Okay, until you can occupy all the electrons for sulfur and calcium. Okay, you don't have to write all the orbitals lah. Okay, obviously, normally the question, okay, the elements that will be asked in the exam normally, of course, the main element. Okay, the main element, and for the transition metal, you'll be starting from row 1 and row 2 only. Okay, alright. Normally berapa banyak kali normally. Usually pula. Okay, usually we ask student to memorize all the elements from first and the second row. Okay, first and the second row of the periodic table. Tapi tu menjawab soalan ke? Saya tak menjawab soalan je. Jawapan dia depends on the number of electron lah. Okay, depends on the number of electron. So you don't have to write all the orbitals in the apa nama tu? In what we have here lah. Tak payah. Okay, as long as you can occupy all the electrons. Dah cukup 20 kat situ. Okay, but nevertheless, the one that I mentioned just now, okay, kita really encourage student to memorize for elements that come from row 1 and row 2. Okay, for row 1 and row 2 of the periodic table. Memorize, memorize in terms of the mass number and also the what we call that, the atomic number. Okay, kita encourage je, tapi still we will provide the info. Don't worry, jangan panik pula. Okay, are you done guys? Are you done? Tahu tak, bila kalau orang tanya, boleh jawab, belum lagi madam, boleh. Boleh, bukan tak boleh, boleh. Tapi kena jawab lah.
Done.
Okay, done. Okay, anybody else who have completed this checkpoint? Or you guys haven't? Please respond, please.
Dah.
Okay, kita ada 2 je yang cakap dah tu. How about the rest?
Dah.
2, 6, 7, 8, 9. 9 baru, ada 90 orang.
Done.
Dah alright, okay, kita consider 10 orang tu mewakili 90 orang lah, macam. Okay, alright. Sulfur, as a beginner, okay, let's start from apa nama tu, tangga tadi, the staircase just now. 1s, 2s, 2p, 3s, 3p. Okay, kita boleh kira untuk 1s kita boleh allocate 2 elektron. 2s and 2p kita ada 8 elektron. Okay, 3s, 3p kalau dia fulfill 3p, 3d and then 4s. So ini 8. So this one kita 2 plus 6 plus 10 will be 18. Ni dah banyak sangat dah ni. So kita boleh stop kat sini lah. Okay, alright. Kalau total it is more than 20 already. Okay, alright. So let's start with 1s and then 2s, 2p, 3s. Okay, 3p, 4s. Okay, so for sulfur, we're gonna start with 1s2. Penuh dah. Dah penuh dah S ni, tak boleh masuk dah lagi dah. Okay, and then next will be 2s2. Penuh dah kat situ. So we have another 12 remaining, okay, electron that has yet to be placed in the orbitals. So after 1s, 2s, and then next will be 2p. Okay, patah balik, looping back. Okay, so next will be 2p. Alright, so kalau fulfill 2p, we have 6. So 6 plus 4, 2, it is equal to 10. So we have 6 more remaining electron. Okay, all right. So 2p6, and then we have 6 more. So next after 2p will be 3s. Okay, 3s. Penuh 2. Cukup tak 16? 6, 10, 11, 12. Okay, we have 4 more electron. Okay, after 3s will be patah balik belakang 3p. Okay, looping back 3p. Okay, kat sini dah be careful Alright, so kalau penuh, p can accommodate 6 electron. Okay, but what we want is for another 10, 11, 12. 4 more. Okay, for 4 more electron. So here should be 4. Kira always recount your electron number. Okay, so 2, 4 plus 6 is 10, 10 plus 4 plus 2, okay, 16. Mesti sama dengan given value. Okay, alright. So this would be your the electron configuration, full electron configuration for sulfur. Okay, for calcium 20 kan, ada tambahan 4 elektron kat situ. So bolehlah pakai yang atas tu. Okay, bertenang. Okay, alright. So kat sini kita ada 6, 8, 9, 10. So we have 10 more to go. Okay, 10 more electron need to have their own room. Okay, for themselves. So here should be 6 lah. Okay, kalau fulfill, and yet we have berapa tadi? 10, 11, 12, 18, baru 18 elektron. So there are 2 electrons yang tak ada rumah lagi. So next will be after 3p, kita akan masukkan the 4s. 4s. Jadi 18 lah, 19, 20. Okay, 2 lah. Okay, so total confirm kan? So ini here kita ada 10. Okay, total kan this one, kita ada berapa? 10, and then it is equal to 20. Okay, betul. This will be your electron configuration for calcium. Okay, right. Yes. Okay. Alright, so that is the first principle, okay? And the second principle is Hans rule. You maybe boleh highlight dekat tajuk dia, dekat saya punya slide, kita highlight using red font. Tapi kalau you guys print without color, everything looks grey. Betul tak? So you highlight kan on your own. So now we are talking about Hans rule. Just now we are talking about Aufbau. Okay. So what did Hans state? So Hans stated that syarat yang kedua, a set of orbital of the same energy level, which is degenerate orbital, the electron occupy the orbital singly with parallel spin before they occupy in pair. Okay, the reason why is because to avoid the repulsion. An atom tends to have as many unpaired electrons as possible. Okay, because same charge would repel. Remember, I told you that the electron and electron, they tend to repel each other. Okay, so one of the way to reduce the repulsion is to stay away from each other lah. That would be the easiest lah. But somehow you still need to allocate 2 electrons in an orbital. So the least repulsion would be felt for the electron is when they spin differently. Okay, bila dia spin seorang clockwise, the other one should be spinning anti-clockwise. Tapi nak represent the clockwise and anti-clockwise, kita guna arrow. Okay, upward arrow, downward arrow. The positive half, the negative half. Okay, alright. So kalau kita boleh avoid, if we can avoid them from if we can avoid them from duduk dekat dalam in one orbital, okay, if we can avoid them, then we by all means kita boleh buat benda tu. So that's why dia kata sini, an atom tends to have as many unpaired electron as possible. Okay, so that is this is the best lah, but somehow, okay, kita kena penuhkan the orbital. So one orbital should occupy 2 electron. So how do we do that? Cara dia adalah cara pengisian. Okay, cara to fill up the orbital. Okay, the most stable arrangement of the electron in orbital is the one with the greatest number of parallel spin. Parallel spin maksudnya they have the same spin. Remember spin ni apa? Ms. Okay, spin. Okay, example. If we were to allocate all the electron for nitrogen, okay, all the electron for nitrogen in the orbital. So how do we do that? Okay, so using the orbital diagram, macam mana kita nak place the electron in the orbital? Okay, for 1s tak ada masalah. Kita kena penuhkan 1s. This is based on Aufbau. Okay, so there is no other way than to occupy the orbitals with 2 electron in the orbital. Dah penuh. Okay, buka 2s. Penuh juga sebab we have and then we have 3 more. Okay, so ini baru 4 electron only. So we have another 3 more electrons. Okay, then kita terpaksa buka 2p kan. Jadi macam buka apa nama tu kata kena buka PPV kan, kena masukkan orang-orang ni kan. Sama juga macam elektron, okay? Alright, so we have to use up the 2p orbitals. Yeah, how do we fill up this 2p orbital? So remember, it's all about repulsion. So how do we reduce the repulsion? So the best way is to fill up the orbital singly. Secara single dulu. Then only, kalau ada extra electron, then only we go for pairing. Faham tak? Okay, so kita ada 3 more electrons kan? So we have 7. So we have placed the 4 electron already. Next, we have 3 more electrons. So the way we place the electron is by putting them ataupun placing them singly in the orbitals. Masukkan 1, 2, 3. Ada lagi extra electron? No, there's no extra electron. That means this is how the electron placement in the orbital. And this is the allowed one lah. Maksudnya this is how the electron are being placed, but not this way. Okay, ini tak apa, ini tak ada masalah. Ini memang dah penuh. Okay, jangan masukkan begini. Penuhkan satu orbital dulu, baru buka satu orbital. Don't do this. Okay, this is only, same goes to d orbital. If d orbital, okay, katalah d orbital, ada 5 orbital kan. So katalah 3d orbital. So we would go for singly dulu. Okay, singly. Katalah dia ada 3 elektron. Then macam ni lah, this is how it looks like. Okay, we don't go for this one. 1, 2, 3. Jangan buat macam tu. Tak boleh. Kenapa? This is repulsion. The repulsion is high. Okay, so cara to reduce the repulsion is to fill the orbital singly, then only you come back, okay, to pair up the electron. Kalau perlulah. Okay, faham ke? Okay ke kat situ? Are you guys doing okay there?
Okay.
Okay, very good. Okay, so this is what we call half filled, guys. Half filled. Half terisi separuh. Half, do not get confused with partially filled. Partially filled maksudnya terisi sebahagian. But halfly filled means terisi separuh. So in total we have 3 kan? 3 orbitals. So kalau terisi separuh, that means there are 1 electron in each orbital. So dia ada 3, so maksudnya ada 3 electron, ada electron in each orbital. That is what it meant by half filled orbital. So this form of orbital is considered stable. Nampak? Macam mana nak stable kan dia? Kena kurangkan repulsion lah, the repulsion of electron. So how can we reduce the repulsion? By placing them singly. Okay, secara single. So kalau all of the orbitals, maksudnya ada setiap satu elektron, so that is what we call half filled. Contoh d orbital here kan, d orbital. So half filled for d orbital will be like this. Okay, so this is what we call half filled orbital d. Full filled ni macam s orbital. Ataupun let's say we have p orbital, so this is what we call full field. Ni full field for p orbital. So that's why lah you nampak saya bila penuhkan saya akan buat macam ni. Okay, to make it a habit lah. Saya tak nak nanti kalau saya buat style penuhkan tu nanti ada tendensi saya terlupa. Okay, alright. So be careful. So Hans highlighted on how to fill up the orbital. So you need to fill up the orbital with electron singly, then only you can start pairing up. Okay, the electron. Okay, that will be for Hans. Macam ni lah. Okay, masukkan secara single dulu. Okay. Okay. Done with Hans. Next we have poly. Okay, so here we have poly exclusion principle. So what did poly say? So poly exclusion state that no two electrons. You dah tahu dah semua ni. Saya ada cakap, tapi saya cakap in general lah. Poly exclusion state. Alhamdulillah. Poly exclusion state that no two electrons in an atom may have the same set of 4 quantum numbers. Okay, so I have highlighted this in the earlier slide. Okay, there is no two electron in atom may have the same set of quantum number. Tak mungkin. At least dia punya MS would be different. Okay, the N, L, ML can be the same, but MS, okay, somehow mesti different. So there is no two electron having the same quantum number, exactly the same from N until MS. Tak ada, tak mungkin. Okay, alright. So each orbital should contain a maximum of 2 electron, betul. Okay, the maximum number of 2 electron in an orbital should be 2. Okay, which must have opposite spin. That's why dia tak mungkin sama, sebab one should be having positive half, the other one should be having negative half. Dia tak boleh macam ni. So this is not the way. Okay, ini tak follow Hans rule ni. Sebab Hans rule, bukan. This is not poly lah, poly exclusion. Dia tak boleh having the same spin. Okay, this is also incorrect because both of them are having the same spin, which is negative half. This is the acceptable one. Okay, this is the acceptable one. The C is acceptable, but not for A and B. Kenapa? Because both of them are having different spin. Okay, ada repulsion tu tetap ada, but at least it is reduced compared to this one, these two. Okay. And then dia cakap electron in A and B are both having the same set of quantum number are not acceptable. Tak boleh. Satu due to repulsion, and then dia disobey the Pauli exclusion principle. Okay? Write the electron configuration for nitrogen, and draw its orbital diagram. So question can be asked in the form of electron configuration and also orbital diagram. So you have 2 questions that you need to address here, okay, for nitrogen. Okay, so nitrogen, the electron configuration will be this 1s2, 2s2, 2p3. So make sure that you total up all the electron, it should be equal to 7. Okay, all right. And then the orbital diagram. So we are done with the electron configuration. For the orbital diagram, guys, please be careful. Okay, the difference is obviously the boxes lah yang kita gunakan. But one more thing is that the superscript that we have for electron configuration is not visible. Okay, for orbital diagram. Should not be visible for orbital diagram. Nampak tak? Kita tak letak dah sini 2 situ. Kita tak letak sini 2 Sini 2, sini 3. We don't do that. Because we have this in the boxes. Kita ada dekat dalam box tu. Buat apa kita nak tulis balik dekat situ? Faham tak? Itu format for the orbital diagram. So, ni tak ada. Okay? Geram pula. Okay, we don't have this. Ni nak buat media marah ke apa ni? Erase all in. Okay. Okay, so it should be 1s, 2s, 2p. Okay, in terms of this, we can represent that using the electron in the orbital. Okay, so 1s2, 2s2, 2p3, 1, 2, 3. Faham tak? Jangan pandai-pandai pergi buat 1s2, 2s2, alah madam, alang-alang lah, letak je lah. Jangan, siapa buat siap tak boleh. This is the format. Okay, this is the format for orbital diagram. You should not include the superscript ni, kuasa-kuasa ni should not be included. Because kenapa? Redundant lah. Okay, it's redundant because we have the electron in the orbital already. So why must we include we include the superscript. Ni superscript yang kuasa kat atas tu we call it as superscript. Okay? Alright. So make sure that you follow Aufbau, you follow Hans and also Pauli. Alright, so we have tag point 5, question 1. Okay, boleh try. An oxygen atom has a total of 8 electrons. Write the set of 4 quantum numbers for all electrons in the ground state. This is interesting. Okay, jom kita buat together. Okay, lambat tunggu awak. Okay, oxygen atom has a total of electron. Okay, this is the time for you to assign the quantum number. So how are you going to assign the quantum number for all the 8 electron for oxygen atom? Macam mana? Okay, so first thing first is to have the electron configuration. Okay, then only we would know, okay, these electrons is belong to s orbital. This electron belongs to p orbital and so on. That is why we need the electron configuration first. Okay, alright, so pakailah awak di ni. Madam dah pro, jadi madam dah hafal. So saya assume lah, okay, kita pakai ni ya. Alright, so for oxygen atom, the electron configuration should be 1s2, okay, 2s2, 2p, 2p4, 4, yeah, 2p4, okay. So in total there are 8 electrons. Okay, now write the set of 4 quantum number. Okay, for the quantum number, this is what saya panggil tips lah, okay. For you, in order for you to be able to see the orbitals clearly, in order to assign the quantum number, it's best for you to use orbital diagram. Okay, it's best for you to use orbital diagram. Boleh, you may use the electron configuration, but dia tak berapa nampak untuk beginner. Okay, for beginner, okay, unless you dah advanced, you boleh nampak. But again, saya really encourage you to draw the orbital diagram if you go for the quantum number. Okay, right. So draw the orbital diagram. So this is 1s. Dia apa kata align. So 2s, 2p ada 3 orbital ya. Jangan lupa p ada 3 orbital. So this is 3p. Kalau lupa kena balik L is equal to 1, ml is equal to -1, 0, 1. Okay, alright. So kita placement of the electron. So we have 2 electron here, and then this one we have 2 electron, and this we have 4 electron. Okay, be careful We have to follow the Hans. 1, 2, 3, 4. Okay, alright. So dia nak 4 quantum number kan? Okay, assign dulu the ml guys. Room number for electron. Okay, room number. Okay, this is kalau S, this one should be 0. Betul tak? The ml for S, okay, it should be 0. Same goes to this one, it should be 0. Kalau lupa, patah balik L is equal to 0, what will be the ml? It should be 0. Okay, alright, so this should be 0. Okay, how about 3p? P orbital kan? So this one should be -1, 0, 1. You dah ada semua ni kan? Dah ready kan?
Madam.
Dia salah ke?
2p ke 3p?
Salah, 2p. Okay, sorry. Okay. Lamanya tunggu baru nak tegur saya. Okay, 2p. Jangan salah macam madam buat because sorry, you akan salah. Okay, no mercy. Okay. Alright. So, when everything is ready now, next thing would be to assign the set quantum number. So go for each one of the electrons. So let's start with this one. 1, 2, 3, 4, 5, 6. Bukan macam tu dia 5, 6, 7. Okay, remember you have to follow the Hans rule. So this is the 5th electron, this is the 6th electron. Jangan pergi dekat sebelah dia sebagai 6 electron. Remember you have to follow the Hans rule. 5, this is the 5th electron, this is the 6th electron, 7 electron, and this one right here is the 8th electron. Okay, itu kena based on Hans rule. So kalau you lupa, you akan 5, 6, 7 dan 8. So salah lah, yang belakang tu semua salah. Okay, alright. So let's go for electron, the first electron. So the first electron, the set quantum number will be, okay, someone please help me to write the set quantum number. What will be the N?
1.
1, then the L? Sorry?
0.
0. ML?
0.
0. And then the
Positive 1/2.
yes, positive 1/2. This would be for the first electron. Buatlah satu-satu. Buatlah satu-satu. And then we go for the second electron. Okay? 1, 0, 0. But now it is?
Negative half.
Yes, that's good. Okay, alright, the third electron. Then for the third electron, the N is now 2. Okay, 2. And then the L is S kan, S is equal to 0. And the ML is equal to 0 still. And then dia pointing up kan, positive half. And so on. Okay, and so on. So, namakan semua lah. Bila you dah nampak, we have everything in the orbital diagram. Next will be you assign lah. Okay, assign which electron you are going to number first. So kena assign. Electron ni electron berapa? 1, 2, 3, 4, 5, 6, 7. And then come back to for the pairing electron. Okay, ni ada lagi lah berterusan. Faham ya? Okay, macam tu. This is what we call application of quantum number. Okay, so imagine if you were asked to write the set of quantum number for the 6th electron in calcium. Okay, the 6th electron in calcium. Electron number 6 dalam calcium. How would you do that? Using these tips yang saya bagi ni, gunalah orbital diagram to help you to identify which electron is the 6th electron for calcium. Okay? Ya Allah, awak tak abang, dah lambat dah ni ha. Okay, alright, so we have write the set of quantum number for the 3rd and 8th electron of fluorine atom Z. So try to complete this checkpoint, the 3rd and the 8th electron. So this is one of the example that I've mentioned just now. Okay, so buat dulu. Fluorine. Okay. Jap. Okay. Can I have your maybe 5 minutes, guys? Boleh tak? 5 minit of your time.
Madam.
Boleh
Yes.
ke? Okay, everybody. Boleh ya. Nanti saya minta maaf lagi ya. Tak perasan tu lah. Okay. Where were we just now? Okay. Dah halang-halang kan kat sini kan? Okay, electron configuration of atoms and ions. Okay, so we have all the principle, all the rules just now. Okay, now dah tahu rules, now boleh kita buat electron configuration. Tapi in fact tadi pun dah buat dah. Okay, cuma we have several types of electron configuration. Ada several types of electron configuration. Okay, alright. If it is mentioned full electron configuration, that means you have to show everything. You have to show all the energy sub-level being filled. Semualah you kena include. For aluminium, so this is the full electron configuration. So starting from 1s until the end, which is 3p, okay, you have to show everything. That will be the full electron configuration. Okay, next we have partial electron configuration. So sebahagian of electron configuration will be displayed. The rest kita compresskan. Okay, shows only the highest energy sub-level being filled. the highest energy sub-level being filled, which represent the valence electron. Okay, ini syarat dia tau. Ini what it meant by partial electron configuration. So from the full electron configuration, always start from the full electron configuration. Okay, you have to identify yang mana yang the highest energy sub-level being filled. The highest. So it depends on the highest n. Okay, as long as dia tak involve 3D lah. Okay, alright. So the highest n sub-level, that will be the valence electron punya orbital, which is n is equal to 3. So jawapan dia will be 3s2 3p1. The rest kita tak tunjuk. Faham? So depends on the question lah. If the question is asking for partial electron configuration, then this will be your answer. The highest energy sub-level being filled. Okay, alright. So aluminium you have to identify. So this will be the highest sub-level lah. Okay, done. Depends on the question. Okay, alright. Next, condensed electron configuration. The word condense itself, like kita compress everything into a form of in this case we use noble gas. Okay, apakah maksudnya itu? Alright. So we use noble gas, the previous noble gas in square bracket. So we use square bracket. Okay, alright. So we have the Z for aluminium is 13, betul tak? Okay, alright. So kita kena tengok periodic table. Kita tengok periodic table. Okay, kat mana periodic table? Macam mana nak tunjuk periodic table lah? Kat sini. Kat sini ada kan. Okay, so we need to use the previous noble gas. Okay, just before the aluminium. Sebelum aluminium tu. Maksudnya noble gas yang tu. Kita jangan guna helium. Here is helium. Okay, dia mesti exactly sebelum that particular element. So aluminium dekat sini kan. Alright, so previous noble gas would be neon. And then this neon is ini 10, sini patutnya berapa? Berapa total dia? 13, 10. So neon alone caters 10 electron. Okay, neon alone caters 10 electron. Faham tak? So that's why dia kata has the element symbol of the previous noble gas in square bracket. Dia mesti betul-betul before the element. Dia tak boleh pakai yang jauh-jauh tu. Helium ke apa ke later on, tak boleh. Dia mesti exactly before the element. So that's why neon dekat sini dah cover 10. Okay, alright. Next we have 3s2, 3p1. So this is 2, this is 1. So total berapa? 13 electrons. See? So this is also another representation of electron configuration. Again, it depends on the question. The question may ask you to write the condensed electron configuration for calcium, for example, as I said, calcium. Okay? So depends. You kena tahu all of these three. How to draw, how to write the electron configuration for these three. Okay? And then from here also, we would be able to determine the valence electron. Valence electron, electron yang duduk dekat the valence lah. The valence shell yang paling luar. Okay, yang paling luar. The highest n. Senang cerita the highest n. Okay, alright. So, dekat mana? Yang the highest n lah, kat sini. So, the valence electron will be 2 plus 1 is equal to 3. Okay, the 3 valence electron is located in 3s and 3p orbitals. Sama juga for full orbital diagram, partial orbital diagram and also condensed orbital diagram. Bezanya tadi dalam keadaan electron configuration, but this one in orbital diagram. Okay, so please yang ni jangan pergi letak pula 6, 2, kita dah ada everything in the orbitals. Okay, alright. So let's just stop there first. We will continue next week. Okay. Alright. Any questions so far, guys? Dia menarik kalau you faham. Hope you guys can do your own revision. Okay, and try to understand. Because if not, you akan miss out banyak lah kat situ. You akan drag lah, you punya tak faham tu, okay? Right. Ada soalan ke? Madam, I have to go. Okay, alright, okay. Thank you everyone for your attention. Okay, see you next week and Assalamualaikum. Bye.
Thank
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.